So the amplitude, when we're graphing sine and cosine, is defined to be the halfway distance, or half the distance, between the min and max on the graph. So we'll show that here in just a minute. So when I'm looking at the graph of cosine, this is what you did in the discovery. You just plotted points. And I like to end this at 360, which is 2 pi. So I start and I end. So that's what we call one cycle. And we also call that a period. How long did it take to repeat that? Halfway between is 180, or pi. So that would be on this unit circle. I'm right here. So now I'm going to go halfway between that is 90. So we're just dividing it into quarters, which is pi over 2. And this is 270, or 3 pi over 2. So that's one graph of cosine. And if you look, the amplitude is half the distance. So from min to max, this is 1, this is -1. So half the distance is an amplitude of 1. Now where did that 1 come from? Well, I'm going to go ahead and draw a coordinate system on this circle. And I'm going to draw the first one being a unit circle. So that means my radius is 1. I still have this right triangle nested in it. That's what trig is. This is x and this is y. So my angle theta, if I find the cosine of that angle theta using SOHCAHTOA, it's side adjacent over my hypotenuse, which is 1, or the radius of the circle. So I can see that cosine is the x-coordinate. Likewise, sine is the SO part of it. Side opposite of that angle, side opposite is y over 1. Remember, it's of that particular angle. So y equals the sine of theta. So that's where that 1 initially came from. Well, how can I make it larger? Well, if I look, I've just taken the circle and I've stretched it. So my radius is some distance, which we're going to call r. Again, this blue distance down here is some value x, and this is still some value y. It's just larger. So again, if I do the cosine of theta and I take the side adjacent, it's still x, but now my hypotenuse is r. It's no longer 1. So now I see that x equals r cosine theta. And how did I do that? I multiplied both sides by r. And likewise, sine of theta is side opposite over this new radius, which is larger. Therefore, y is equal to r sine theta. So this letter r is the stretching of the circle. So we have this form. Y equals a sine theta, where a is the amplitude, or y equals a cosine of theta. And the a, again, is the amplitude, or the stretch or shrink of that circle. So if I put a 2 out here, it just means my radius is 2. So instead of going out to 1, I'm actually going out to 2. So on my unit circle, it's 2. It's no longer a unit circle. So I'm going to graph cosine. I always like to start a little bit beyond this 0. So again, this is 2 pi, or 360. So you're going to have to label these. And notice I'm starting here and ending here, and I'm just going halvesies. My graph isn't perfect. Half of 180 is 90, or half of pi is pi over 2. So I'm counting by pi over 2s. And I also know that's 370. So the only thing I need to do now is look, this is my amplitude. And so how much did it stretch? It's no longer at 1 like the unit circle. It's down to 2, a -2, and that's called the amplitude. It's halfway between, okay, the large and the small. So what happens if I have a negative and a half? Well, the negative says, just like it did on going around the unit circle, it says to go down. So a negative on the number line says to go to the left. So negative graphing is going to, instead of going up, we're going to start down here. So again, notice my cosine was a flip. So it just made everything that was positive negative. So here's 2 pi, here's pi over 2, and this is 3 pi over 2, and I'm going to label this now. I'm not drawing these to scale, but this would be -1/2, and the upper would be 1/2. So it just tells me the direction around the circle in which to travel. So let's look at the same thing for sine. Sine for me is a little bit easier to graph just because I'm starting at 0. Again, 2 pi, pi, and you can use on these angles in degree form or in radian. That would be your choice, but it still takes one way around the circle or 2 pi, or 360 degrees. And the amplitude is still 1 if I'm initially getting it off the unit circle. So I like to label that as well. So this 3, notice it's found in the amplitude. So it says I'm just looking at a triangle that has a radius of 3. In other words, the circle has a radius of 3, which became my hypotenuse. So again, I just graph sine. So all you're going to have to be able to do is kind of pick that off. This is 3, this is negative 3, and I'm going to complete it. This time I'll put it in degrees. So what your homework is going to consist of is identifying that hypotenuse.